Look at this JEE question. It is not a routine Venn diagram question. It uses a concept of weightage that is inbuilt in Venn diagram. You have to explore this concept, and if you understand this one hidden idea, you can solve this question in just under 2 minutes. Look at this diagram. It's a Venn diagram, but we are going to use a weightage concept here. You see that it represents three sets. In this case, may you take it as physics, chemistry, and mathematics. And A, B, C are three values marked within the overlapping regions, and X is also there. See, A, B, C are actually they are lying in the areas where there is double overlapping. Two sets are overlapping. So what is important is that though these values are counted twice, they are 2 times counted. When it is A, it means 2 A students. When there is B students, it is 2 B students. This they are counted twice, and the value which is in the triple overlapping region, all the 3 sets overlap is counted thrice. Then see, by comparing the number of students passed with the number of students actually appeared, we can find this, or we can see, we can substantiate. Why do we say so? See, appeared is 40. Past is math is 20, physics is 25, and the chemistry 16, all put together 61, and there is excess of 21. How come? Number of students passed cannot be more than number of students appeared. It is not so, but it appears. Why? Because of the excess counting. So when we want to maximize N of A intersection B intersection C, we have to maximize or assign this maximum count to the overlapping regions only because of either double counting or triple counting this excess appeared, otherwise it cannot be more than 40. Since we want to maximize X, we can assign the entire 21 excess count to X and see what happens. We know triple over counting, so suppose we assign the value of X to this N of A intersection B intersection C, X would have been counted thrice. So should have been counted once, should have been counted thrice. So X has become 3X. So actually the excess is, what is the excess? 3X minus X, which is 2X. And now we say this excess of 2X equals 21. And the X is 21 over 2, which is 10.5. And since a student cannot be 10.5 students, so we have to restrict to 10. And now let's discuss about constraints. When there is an inequality, there is a constraint. So the constraints gives us a range of values, but also boundaries within which you have to act. See, the constraint here is a double overlapping area should not be less than the triple overlapping area. It's a common sense, all of you know, no? So we have to ensure that the double overlapping areas, what are they? A intersection B, A intersection C, and B intersection C, all should be more than N of A intersection B intersection C. We have arrived the value as 10. What is the 10? N of A intersection B intersection C is 10. And now let's see whether the constraints are met or the constraint is met. So given is N of A intersection B is less than equal to 11, and A intersection C is less than equal to 15, and B intersection C is less than equal to 15. So we know that all these 3 double overlapping areas are more than the value we arrived at, or we assigned the maximum value for N of A intersection B intersection C. Hence the constraints is actually addressed. That's the correct word you have to say. No? Constraint is addressed. So hence now we can confidently say that the maximum value A intersection B intersection C can take is 10. So if you like the video, comment, subscribe, and share it to your friends.